Okay, so today we're going to start talking about chemical equations and reactions. So, some basics. A chemical reaction is the process by which one or more substances are changed into one or more different substances. So, this is a review of the first unit. In any chemical reaction, the original substances are known as the reactants, and we know that reactants are on the left of the arrow, and the resulting substances are known as the products, which are on the right of the arrow. And according to the law of conservation of mass, the total mass of the reactants must equal the mass of the products for any given chemical reaction. So, some indications of a chemical reaction. We know evolution of energy as heat and light, production of a gas, formation of a precipitate, which we know that is a solid, and the fourth one, a color change. A little bit later on in this unit, we will do a lab devoted to evidences of chemical changes. So, a review from last unit, we're going to count the number of atoms in a compound. So, for example, say we had Mg3 parenthesis PO4 parenthesis 2. So magnesium phosphate. So I look here, I have 3 magnesium atoms in this compound. Now, if we have a subscript outside of parentheses, we're going to distribute this 2 to each element in the parentheses. So we'll have 2 phosphorus atoms and 8 oxygen atoms. Now, if I had one like this, I had a 2 in front of sodium chloride. This 2 will be distributed to each element in this ionic compound. So we'll have 2 sodium atoms and 2 chlorine atoms. And one that we haven't seen before, if I gave you something like this, if I had a 2 Pb parenthesis C2H3O2 parenthesis 2. So we know this is lead 2 acetate. But now, how many lead atoms do we have? So this 2 distributes to the lead. So we have 2 Pb. Now, this 2 is distributed to each term in the parentheses. But then we're also going to multiply that number we get by the 2 in front of the Pb, because that goes to each term in our ionic compound. So we have 2 times 2 is 4 times 2. So we have 8 carbons. We have 12 hydrogens. And we have 8 oxygens. So a chemical equation represents with symbols and formulas the identities and relative molecular or molar amounts of the reactants and products in a chemical reaction. So we see in this equation, we see our 1 reactant, ammonium dichromate, and our 3 products. Remember, products are the right of the arrow, reactants are to the left. And we see a few charts here that deals with the symbols that are used in a chemical equation. And we will continue this on the next slide or next page. And to wrap up this video, a few things. Characteristics of chemical equations. The equation must represent known facts. So the information in these equations must be true. We can't have anything, any types of fiction. Number 2, the equation must contain correct formulas for the reactants and products. And number 3, the law of conservation of mass must be satisfied. And this last topic here is very, very important to chemical equations. A coefficient. And a coefficient is a small whole number that appears in front of a formula in a chemical equation. And that wraps up our first video in our chemical reaction